guess what day it is today? Today is Charles Darwin's birthday. Yay! Voices in order now. We're all going to sing Happy Birthday, Dear Charles. Are you ready?
Happy birthday to you. Happy birthday to you. Happy birthday, Charles. Happy birthday to you.
There will be birthday cake afterwards. Thank you for our guest joining us. I'm Rob Dillon. I'm from the biology department here at the college. I'm the host of Darwin Week, 15 years in a row. And, can you believe it? You know, I remember Charles Darwin is 206 years old today. I remember him when he was just 100. So, 15 years we've been having Darwin Week. And one of the things, the emphasis of this week has always been the diversity of thought, the diversity of disciplines, the wide reach that Charles Darwin has had across the intellectual landscape of the world, really. And of course we have a lot of science. We have a lot of biology. We have a lot of geology. We have a lot of cosmology. We have anthropology. That's obvious. And actually most of it will be science, no question about it. But we have a lot of religion too. We have every year we've had something in a church or a synagogue or whatever, a lot of religion. And we have movies, we have poems, but we have never, in the 15 years of Darwin Week, had an artist. This is the first time ever. I'm so thrilled to be able to introduce to you all Ms. Emily Willoughby. She is a scientific illustrator, and she does, in fact, work with scientists and publish in major journals in science or nature or evolution, working with paleontologists to reconstruct what extinct creatures did look like. She also does a lot of work with popular magazines like National Geographic, and she has some books, I want to say, several children's books on dinosaurs. She does illustrate, and museums, am I right? Museums. So you do dioramas or murals or whatever, I guess, in museums. Paintings, that's right. She is an artist. She's also an author. And she's working on a book right now. She's written at least one or two before. She's working on a book right now. She's going to tell us. There's some seats down front. You all who came late, straggling in here, Dr. Donald at all hours, Dr. Kogan wandering in here 2 minutes late. Oh, he's going to sit in the window well. Okay, so anyway, yes, so she is an artist, she is an illustrator, she is an author. Please put your hands together and give me a warm Charles Darwin welcome from Ms. Emily Willoughby.
Can everyone hear me?
Yeah.
Like every other man of intelligence and education, I do believe in organic evolution. It surprises me that at this late date, such questions should be raised. Wouldn't Woodrow Wilson, who wrote this in 1922, be shocked to learn that rejection of evolutionary science remains strong in the United States almost a century later? So most people are at least familiar with what creationism is in a basic sense, but what exactly is it that creationists believe? Well, creationism is basically the belief that the creation story presented in Genesis is an accurate historical account. This usually involves the belief that the world is around 6,000 years old and that humans were created in more or less their present form, and also that most of the fossil record was deposited by Noah's flood. All of these beliefs don't always go together. For example, there are some creationists who believe that the Earth is actually billions of years old, but that every new group of animals that appears in the fossil record was created by God directly. But the most common and influential kind of creationism is young Earth creationism. And this is the kind advocated by major creationist organizations like Answers in Genesis. So, how many Americans are young Earth creationists? Well, last year's Gallup poll found that 42% of Americans believe that God created humans within the past 10,000 years. This figure has barely changed since Gallup began the poll in 1982, oscillating consistently between 40 and 47%, as you can see up here. Notice that this has changed very little since the poll first was started. So clearly Wilson underestimated the powerful long-term effect that a cultural divide can have. The divide that existed in his time has, if anything, strengthened by today. In Wilson's time, it wasn't uncommon for politicians to believe in what they called organic evolution, including Wilson's two major opponents, William Howard Taft and Theodore Roosevelt. But nowadays, conservative U.S. politicians cannot claim a belief in evolution and hope to be successful. Both sides ought to be properly taught so people can understand what the debate is about. Much of this conservative sentiment is familiar to all of us. Some sidestep the issue by saying that we should teach the controversy, such as George W. Bush during his second term. All that stuff I was taught about evolution and embryology and the Big Bang Theory, all that is lies straight from the pit of hell. And it's lies to try to keep me and all the folks who are taught that from understanding that they need a savior. Other conservative politicians, like Georgia Representative Paul Brown, have no problem ducking the question since they emphatically disagree with the widely accepted answer. Not only is the man who said this a congressman, he's a member of the House Committee on Science, Space, and Technology. Anti-evolution sentiment has not only survived since Wilson's day, clearly it is thriving. So what are we doing wrong? What has theology ever said that is of the smallest use to anybody? When has theology ever said anything that is demonstrably true and is not obvious? What makes you think that theology is a subject at all? Statements like this openly mark Dawkins and similar writers as outsiders to religious culture. Religious outsiders can only ever preach to the choir, or the non-religious equivalent, without any realistic hope of reaching that 40 to 47% of Americans who side with creationism in the Gallup poll. A lot of people have suggested that the Dawkins method of unapologetic disapproval for religion actually does work, and that it's responsible for a higher rate of creationists coming to accept evolution. But this is supported neither by studies in human psychology nor by the available data. Research has consistently shown that people who reject the theory of evolution are, on average, no more ignorant about evolutionary science than people who accept it. In other words, creationists do tend to know the basic facts about evolution, but they still choose not to believe it. In my view, attacking Christianity as a tool for advocating evolutionary science is not only ineffectual, but it's patently irrelevant as well. Most Christians worldwide are not creationists, and Christians have some very respectable advocates of evolutionary science, including biologist Kenneth Miller. The scientific method, when correctly applied, is able to shield results from one's personal biases. If a person knows how to make use of the scientific method while conducting and reporting their research, then they will be able to uncover truths about the world and can advance scientific knowledge regardless of the content of their religious or spiritual beliefs. So why does the Dawkins method not work? Well, my theory is that it runs counter to human nature in a number of ways. For example, a lot of studies in social psychology have shown that the more similar two people's values are, the more easily they can persuade one another to consider new viewpoints. The inverse is also true. When an individual is insulted by a communicator attempting to persuade him of a viewpoint, the individual is more likely to strengthen the resolve and extremity of their original viewpoint. This is known as the boomerang effect of negative persuasion. You may have noticed this in your own arguments with people. Research in behavioral genetics has also suggested that religiosity itself is something that varies innately between individuals, and that the predisposition to religious worldviews is heritable. This is consistent with the finding that religious belief is a human universal, meaning that every human culture on Earth has some form of religion. The implication is that religion is more than a cultural fixation. It's a product of our inborn psychology, at least for some of us. Expecting a religious person to give up their faith is like expecting a right-handed person to start using their left hand. In the last few decades, there has been an enormous wealth of public outreach for education on evolutionary science. And some of these books, including a lot of Dawkins, are extraordinarily good. But most of these have one of two things in common. They do not offer Christians any hope of consilience between theology and science, or they were written by authors who have little familiarity with the creationist technical literature, and thus they ignore creationists' most important arguments. And creationists do actually publish science that gets accepted in journals, and a lot of people don't seem to realize that. So if these things don't work, then what does work? So the material presented in this talk is based on a book that's currently in pre-publication by 5 former creationists who've each written a chapter on their area of specialty. Unlike most other books on this controversy, we cover in great depth a number of creationist arguments that are defended by Answers in Genesis. Our introduction by me describes how creationism is a problem in the United States and what approaches do and do not work. Chapter 1 by Jonathan Kane defends the use of reason when dealing with matters of theology and science. Chapter 2 by geophysicist Glenn Morton argues for an old Earth from geological evidence. My Chapter 3 argues the same from radiometric data. Chapter 4 by Jonathan Kane discusses bird origins and dinosaur evolution. And Chapter 5 by T. Michael Kesey argues for human evolution. And our final chapter by historian Jim Comer shows how a literal reading of the Bible is bad theology. So, taken together, this material explains not only why our God-given reason leads to acceptance of evolution and an age of the earth measured in billions, but also why a literal interpretation of Genesis is bad theology. I've shown how creationism remains stalwart in the U.S., and how attempts at diminishing its power seem to not be working. I'd like to demonstrate that it is possible to convince creationists of evolution, and I'll be using the evolution of dinosaurs and birds as an example of how this might be argued. But first, we need to acknowledge that acceptance of evolution does not threaten a Christian's relationship with God. Contrary to the prevailing wisdom, I don't think that creationists are totally closed to new ideas. In fact, we think it's possible to interpret the Christian Bible in a way that leaves space for evolution. How many are your works, O Lord? In wisdom you made them all. The earth is full of your creatures. When you hide your face, they are terrified. When you take away their breath, they die and return to the dust. When you send your spirit, they are created, and you renew the face of the earth. These verses from Psalm 104 describes God creating animals to renew the earth after others have died. Interestingly, the word create used here in the Bible is the Hebrew word vera, which is the same word used to describe God creating animals in Genesis. So it's difficult to reconcile this passage with a young earth perspective, because if the world and all its animals were created in 6 literal 24-hour days, there would have been very little that died and needed to be renewed during that period. But this passage is consistent with the view that God's creation took place over a much longer period, in which he periodically renewed the earth after earlier groups of animals had become extinct. With this interpretation, consistent with Scripture, it seems reasonable that God could have created the earth and started the process of evolution long before man. And there's a lot of stuff like this in the Bible that can be interpreted this way, and we cover a lot more of it in our book. All that has come into being since, except the souls of men alone, has arisen as a modification of this original world stuff by means of the interaction of its intrinsic forces. And this is not only evolutionism, but pure evolutionism. Creationists can also take the lead from famous, well-respected Christian theologians like Benjamin B. Warfield. Christians like him and C.S. Lewis strongly believe in the use of reason to understand the universe. The use of reason presents an interesting case because a lot of creationist leaders actually claim that reason is incompatible with God's word, but Christians need not accept that. Images like this from Kentucky's Creation Museum demand that Christians choose one or the other, God's word or human reason. The Creation Museum tells us that God's word and human reason are in contradiction, and that therefore it is God's word that we should trust and human reason that we should ignore. I do not feel obliged to believe that the same God who has endowed us with reason, sense, reason, and intellect has intended us to forgo their use. Galileo said this 400 years ago. It represents the opposite perspective from this, that reason is a gift from God, and that for us to avoid using it would demonstrate a lack of gratitude to Him. So, for Christians, which of these viewpoints is correct? And which can be, if one can be considered correct or incorrect at all? Is there a definite answer to this question, or is it merely a difference of opinion where either answer is equally valid? I'm going to try to demonstrate that neither the Dawkins method nor the creationist method is necessary for Christians to come to an accurate understanding of the evidence without compromising their faith. Most of us learn to trust reason from an early age. It is only when what we observe appears to run counter to the Bible that anyone would have a problem with this idea. If the Bible is the greatest authority that exists on all matters for Christians, then according to some viewpoint, it should be trusted more than any other source of information, even more than our own eyes and ears. But even the most devoted creationists must admit that sometimes using reason is unavoidable. If you ask any Christian why they trust the Bible, and not any of the other religious texts out there that claim to be divinely inspired, they'll usually give you an answer that's based on reason. For example, they might say that archaeology has confirmed that some of the Bible's accounts about ancient Israel are true. And that means basically that we should trust the Bible because it's been supported by physical evidence. But how can we then use the Bible as a basis to reject physical evidence when the two seem to disagree? And a similar question, how can you place more trust in the Bible than in your eyes, when your eyes are the only way of actually reading the Bible? Ultimately, whatever we believe about the Bible, our ability to understand anything about the world still depends on how we physically observe it. On this basis, science should be as important to Christians for learning about the nature of reality as theology is. It is through science that Christians can more fully understand the workings of God's creation and better appreciate His glory as its designer. For science is more than just a set of teachings. It is, above everything else, a quest for understanding. Science seems to me to teach in the highest and strongest manner the great truth which is embodied in the Christian conception of entire surrender to the will of God. Sit down before fact as a little child. Be prepared to give up every preconceived notion. Follow humbly wherever and to whatever abysses nature leads, or you shall learn nothing. Thomas Huxley, one of Darwin's earliest supporters, put it best. Reason enables Christians to explore the beauty of our world in a way that nothing else can. Evolution, as a process, in all of its elegance, does more to exalt the concept of God as a brilliant designer than it does to detract from Him. In order to effectively combat creationism, we need to urge creationists to learn about the world using God's gifts of reason. For only then can God teach them lessons provided by the world that He has made. Answers in Genesis is one of the most powerful creationist organizations in the world. Their Creation Museum in Kentucky is technologically on par with most other major museums. But obviously, it differs in one important way. It is devoted to the concept of trusting the Bible over human reason. Much of the museum's information and exhibits is supported by publications, from books to actual scientific papers and articles that are written by scientists employed by Answers in Genesis. Here I'll be focusing on their arguments related to dinosaurs and birds. But first, it's important to understand some of the background to their arguments. This chart is from the Creation Museum, and it shows how creationists believe that all dogs, wolves, and foxes are descended from a common ancestor. So a lot of people don't seem to realize that creationists do believe that a certain amount of speciation is possible. And a basic understanding of Genesis makes it obvious why. Every air-breathing animal alive today has to be descended from animals that fit on Noah's Ark. And this is how they explain that. The issue comes from the limitations that creationists think are inherent to evolution, that one created kind cannot turn into another, and that mutations and adaptations cannot provide new biological structures and functions. Creationists think that animals can speciate, but only within their kind. So this is basically the same thing as microevolution, where they think that these basic forms of organisms can change into lots of different kinds, but they cannot actually cross over. And here is the way that mainstream biology thinks of evolution, where animals branch into lots of different forms. So biologists consider microevolution to be a form of evolution, but creationists draw a line between the two. And most scientists also accept that mutations and adaptations can produce new structures and functions. One of the best examples of that in action is the bacterium Flavobacterium. And this fascinating genus has evolved the ability to digest nylon waste. But nylon has only been around since the 1940s, so how is this possible? It works by altering enzymes that are normally used to digest carbohydrates. So these enzymes are no longer effective on carbohydrates and only work on nylon. And mutations like this often occur when a gene is accidentally duplicated and the extra copy is free to mutate into all sorts of different forms without compromising the function of the original gene. So if we can accept that mutations and adaptations can give rise to new genetic information, then clearly it's not impossible for one created kind of animal to give rise to another. When presenting the evidence of this phenomenon to creationists, the evolution of birds from a dinosaurian ancestor is one of the most complete and robust demonstrations of this in action. Huxley first proposed the idea that birds are descended from dinosaurs in the 1860s. This was based on anatomical similarities that he noticed between modern birds and small members of carnivorous dinosaurs called theropods. A central element of Huxley's argument was based around Archaeopteryx, shown here, which seemed at the time to be a functional midpoint between dinosaur anatomy and modern bird anatomy. Huxley proposed on this basis that Archaeopteryx was a transitional fossil. And while this wouldn't be confirmed for certain for over a century later, we know today that Huxley was right all along. Embryology is one of the first areas of research where Darwin's theory of evolution is applied. This field describes how animals develop inside of a womb or an egg. And here's a chicken embryo that's fairly late in development. A central concept of embryology is the idea that an animal's embryo may contain remnants from earlier in its evolutionary history, and these remnants then disappear when the animal matures. This is because as an animal acquires new adaptations, sometimes these adaptations only affect later stages of the embryo while leaving the earlier stages of it unchanged. So the most interesting example of this in action comes from William Beebe, an early 1900s naturalist and ornithologist. Beebe observed that many bird embryos seem to develop feathers on the legs that are almost as long as those on the arms. These are some photographs from his research of a baby pigeon, and you can see the feathers on its legs, here and here. And here's a drawing that he did of them up close where you can see. So Beebe noticed also that Archaeopteryx had what appeared to be the remnants of feathers on its legs. And he concluded that it must have been in the process of losing them. So why would these baby birds have these feathers here? Well, based on this, Beebe predicted that birds must have gone through a transitional stage earlier in their evolution where they had long functional leg rings. And he drew a picture of this, and he called it Tetrapteryx, which means 4 wings. And he imagined that it would have glided. So Beebe didn't live to see his prediction come alive. But in 2003, the first 4-winged dinosaur was unearthed in Liaoning, China. And this dinosaur is basically exactly what Beebe predicted. It's a dinosaur more primitive than Archaeopteryx that had fully developed flight feathers on its legs. And it would have been gliding pretty much just like he drew it. A similar example happened around a decade later when Danish paleontologist Gerard Heilmann published a detailed analysis of all of the evidence that had been produced on this topic so far, called The Origin of Birds. His conclusion was that birds did not evolve from dinosaurs, but from some more primitive group of reptiles. This was based on his observation that birds have wishbones, but no known dinosaur fossil at the time did. No known dinosaur fossil even had clavicles, which are the bones in the collar that fuse together to form a wishbone. Whatever birds evolved from, Heilmann reasoned, it must have had clavicles. At the time, the only fossils that had any similarity at all with birds are called pseudopseudians, and these were a group of crocodile-like reptiles from the early Cretaceous. In the 1980s, a new analysis of the dinosaur Oviraptor revealed an element of its anatomy that had been totally overlooked. This animal had a furcula. As it turns out, the reason why dinosaur furculae were unknown when Heilman wrote The Origin of Birds is not because dinosaurs didn't have them, but because so few dinosaur fossils had been found in Heilman's time that nobody had yet found one in which this particular bone was preserved. Furcula have now been found in around a dozen different dinosaurs, including Allosaurus, Daspletosaurus, and Velociraptor. Beebe's Tetrapteryx and Microraptor, and the wishbone and Oviraptor demonstrate one of the most important features of the theory of evolution that makes it categorically different from anything that creationists have to offer, and that's the power of prediction. Like any robust, well-supported scientific theory, evolution allows us to make inferences about the universe. Evolution's predictive power is what made Beebe know that Microraptor must exist almost a century before it was discovered. When it comes to things that modern birds have in common with extinct dinosaurs, those examples are barely touching the tip of the iceberg. People started really noticing how similar theropod dinosaurs were to birds in the 1960s. This was in large part due to paleontologist John Ostrom's discovery of a wolf-sized carnivorous theropod called Deinonychus. And that's what its skeleton looks like, and here I've reconstructed how I think it would have looked when it was alive. Deinonychus was a dromaeosaur, which was a family of bipedal carnivorous theropod dinosaurs with long, stiff tails and large grasping hands and lots of teeth and hyperextendable second claw digits. Ostrom noticed almost immediately that Archaeopteryx seemed to look really similar to this, more similar than anything else that had been described from a complete skeleton at that point. So, with the comparison between Archaeopteryx and Deinonychus as his starting point, Ostrom started to reconsider the idea that birds were, in fact, directly descended from theropod dinosaurs. Here's a comparison between the skeletal anatomy of Deinonychus, Archaeopteryx, and a modern pigeon. The idea here is that creationists unequivocally consider Archaeopteryx to be a kind of bird. But as you can see here, Archaeopteryx skeletally looks a lot more similar to this dinosaur than it does to a modern pigeon. So here are a handful of examples. Archaeopteryx has teeth, and so does Deinonychus. Modern birds completely lack teeth, hence the phrase, rare as hen's teeth. The spine of Archaeopteryx enters its skull from the back, and as it does in Deinonychus. In modern birds, it's most typical for the spine to enter the skull from the bottom. Archaeopteryx has ventral ribs called gastralia, and so does Deinonychus and a lot of other theropods. Birds obviously have a totally different structure here, a keeled sternum. Archaeopteryx has a long bony tail, and so does Deinonychus. All modern birds have short tails, and the last few vertebrae have been fused together into a bony stump called a pygostyle. And this is used for controlling feather fans. And you can also see the hands are very similar, and the feet are very similar. And both of those are pretty different in birds. Here's a more detailed comparison of the feet. This is a comparison between a primitive dinosaur called Coelophysis, Deinonychus, Archaeopteryx, and a pigeon. The three long bones in the upper foot of Coelophysis and Deinonychus are called metatarsals. And you can see that in these animals, these bones are totally separate. And in Archaeopteryx, they're mostly separate, but they're sort of starting to fuse together. And in modern birds, these bones are totally fused together, and this is a totally different structure called a tarsometatarsus. But embryos of modern birds still contain the three separate metatarsals, and these fuse together before the bird hatches. The nubbin of a fifth toe that you can see up here is another example of something that's found in primitive birds as well as theropods, but is unknown in modern birds. This is an important piece of evidence that Archaeopteryx is related to theropods, because it cannot be explained by a common design argument. While it could be argued that some of the anatomical similarities between these animals are because God reused an effective design in more than one place. This does not explain why two unrelated animals would have also had the same non-functional body parts. Here's a closer look at the hand and arm bones of some of these animals. This is a comparison between Deinonychus, a related smaller dromaeosaur called Sinornithosaurus, Archaeopteryx, a primitive bird called Confuciusornis, and a modern pigeon. Note the crescent-shaped bone in the wrist of Archaeopteryx, Deinonychus, and Sinornithosaurus. It's kind of hard to see, but it's right there. This is called the semilunate carpal. This is a unique bone found in no other animals except for bird-like dinosaurs and primitive birds. This bone acted as a sort of swivel joint, which allowed the animals to hold their hands in a sort of grasping motion or to bend it like they were folding a wing. The semilunate carpal is also present in Confuciusornis, but only in very young individuals. In more advanced birds like the pigeon, this bone has totally fused with the hand bones. And you can see a sort of bony protrusion here that's a sign of where it used to be. The evolutionary explanation for the similarities between Archaeopteryx and theropods, and the differences between it and modern birds, is that they exist because Archaeopteryx was descended from a dinosaur lineage that had evolved flight very recently. The anatomy of most theropods was well suited to chasing and catching prey, and that includes the sharp teeth, the strong grasping hands, the bony tail that acted as a counterbalance while it was running, and other things. Archaeopteryx would have inherited all of these features from its dinosaurian ancestors. Yet, even as these features had been very useful for catching prey, Archaeopteryx and its descendants discovered that they also have a downside, which is that they don't make for an especially good flyer. Flexible clawed fingers are not the sturdiest option for supporting wings, and teeth and a bony tail make the animal heavier, so it must have had to expend more energy getting off the ground. In birds that were less primitive than Archaeopteryx, it therefore provided an advantage to gradually abandon these features in favor of an anatomy that's as well suited to flight as possible. Although natural selection is often described as survival of the fittest, whether a characteristic makes an animal more or less fit is often completely subjective, and it depends on the animal's lifestyle. Anatomy is not the only clear similarity between dinosaurs and birds. We are profoundly lucky to have a handful of fossils that actually show something about the dinosaur's behavior. And some of these behaviors are things that are only known in birds. This is the fossil skeleton of Psittipati, which is an oviraptorosaur. These were also bird-like dinosaurs and are kind of related to dromaeosaurs, but they're a bit more primitive. So note that this fossil, its arms are here, and its legs are sort of tucked underneath it. And it's sitting on a bunch of eggs. These are eggs here. So what does it look like this dinosaur is doing? It's basically brooding its nest, just like a big hen, pretty much. Psittipati isn't the only example of bird behavior preserved in a dinosaur. The tiny dinosaur Meilong, shown here, died in a volcanic ashfall 125 million years ago. It was sleeping when it died, and its head is tucked under the elbow of one wing, exactly the way that modern birds sleep. May belonged to a group of dinosaurs called Troodontids, which, together with dromaeosaurs like Deinonychus, form a group that's now considered by most paleontologists to be a sister clade to birds. The sleeping fossil of Meilong has become one of the most iconic dinosaur fossils, and a lot of paleo artists and scientific illustrators have drawn it sleeping, but just to be contrarian, I've drawn it here running, like it was hunting or escaping from predators or something. Funnily enough, a couple of years ago, a new specimen, a second specimen of this dinosaur was discovered, and it was also sleeping. I think it was curled up in the opposite direction from the original. So what are the odds that the only two specimens of this dinosaur would both be sleeping? So maybe this is inaccurate and this dinosaur was just like sleeping all the time. So the idea that Deinonychus and other dinosaurs were covered in feathers is another prediction enabled by evolutionary theory that has now been proven correct. If birds are descended from dinosaurs, feathers would have had to exist before flight did. What use would feathers have been to a non-flying animal? Well, one paleontologist who proposed an answer to this question was Gregory S. Paul. In his view, the first feathers were simple precursors to those that originated in dinosaurs, and these served the purpose of keeping their bodies warm. In some of the animals, their feathers would have been elongated into fringes of feathers like this on the arms. And he thought that these feathers could have eventually been modified into functional wings. Greg Hall first proposed this idea in his 1988 book, Predatory Dinosaurs in the World. And here's an example of how he thought that they would have looked. This is a velociraptor, and I think this is a troodon. And they're fighting over a carcass of some kind here. And it's kind of hard to see, but you can see the date down here is 88. So Greg Hall was able to predict that these animals would have feathers quite a long time ago, before there was any actual evidence of this. And his conclusion is another example of a prediction that the theory of evolution can show whether it's correct or not. And in the mid-1990s, a previously unknown group of fossil formations was discovered in the Liaoning province of eastern China. And these formations were unusual, both for the amount of volcanic ash they contained and for the extraordinary preservation of many of the animals found there. The volcanic eruptions of Mesozoic Liaoning would have buried the animals that lived there so quickly that their bodies didn't have time to decompose. This makes Liaoning one of the only places in the world where it's possible to find fossils of dinosaurs that show something about their skin coloring. The only other place where this is well known is Solnhofen in Germany, the limestone quarries there, and this is where Archaeopteryx was found. The following is a selection of 11 feathered dinosaurs, both from Liaoning and elsewhere, that demonstrates a rough continuum from less bird-like to more bird-like. This is basically macroevolution in action. Each one of these animals is pretty similar to the one on either side of it, but those at each end are very different. Sinosauropteryx prima was the first discovery ever made of a dinosaur fossil with preserved skin showing something other than scales. The fossil of this animal has a covering of fuzzy fibers extending from its neck all the way down to the end of its tail. And you can sort of see this here. Although these fibers have a superficial similarity to fur, they are much thicker than the hairs of mammals, and unlike hair, they appear to be hollow too. Some critics have alleged that the fibers found on the fossils of Sinosauropteryx might be something other than feathers. Perhaps they're fibers of collagen, a type of connective tissue. But there's a serious problem with that idea, which is that in 2010, a study found that these fibers actually contain traces of pigment-bearing organelles called melanosomes. These are the same structures that give feathers of modern birds their colors. And these organelles are not found in collagen, only in feathers. So along with providing evidence that the fibers preserved on Sinosauropteryx were definitely some type of feather, this discovery also allowed scientists to know for the first time something about a dinosaur's colors. These melanosomes can be analyzed microscopically and compared to structure in modern birds. And this analysis revealed that its tail was banded, like a raccoon's tail, and that's how I've drawn it here. Ornithomimus edmonticus is known from North American formations. This dinosaur belongs to a group known as ornithomimosaurs, and these are distinguished by long legs, long necks, small heads, and they may have been among the fastest running dinosaurs. Unlike most theropods, ornithomimosaurs do not usually have any teeth. Ornithomimus has been known since 1933, but the first evidence of it being feathered came in 2012, I think. Paleontologists in Alberta described a new fossil of an adult and two juveniles that were preserved together. It may have been apparent to too young. And all three of these skeletons are surrounded by a covering of hollowed down-like filaments. They're pretty similar to the same structure of these things in Sinosauropteryx. And the adult has something not found in any of the youngsters. It had a series of long, stiff ratchets on its arms. So just as some birds alive today have ornamental structures that only appear when the animal's an adult, it looks like only mature ornithomimus had these wings. And nobody really knows for sure what they would have been doing with them. Maybe they were displaying to mates or something like that. But as you can see, the young ones didn't have anything like that. Caudipteryx zui was a turkey-sized oviraptorosaur similar to Cytopet, the egg-brooding big mother hen. All of these dinosaurs have sort of parrot-like beaks and relatively short tails and long legs. And as you can see from the fossil, Caudipteryx had fringes of feathers on its hand here, and also long feathers on the very tip of its tail, which is what it's named for. And all of these feathers were considerably longer than any of the feathers found on Sinosauropteryx. It is also a step beyond in how similar its feathers were to those of modern birds. Each feather contains 2 rows of barbs attached to a central shaft. Caudipteryx's arms were way too short for it to have been flying, though. So here's another example of a dinosaur that was probably using these wing-like structures to display to rivals or to potential mates or to help protect its eggs or something else like that. Epidexipteryx huey was a Scansoriopteryx, and this is a very strange group of theropods that they may have been tree climbers. This one in particular had a very strange skull with protruding buck teeth on the lower mandible, and nobody really knows what it was doing with those. But most interestingly, the fossil was found with these 4 really elongated ribbon-like tail feathers. And this dinosaur also has a pygostyle. These feathers are very similar to the sort that you would expect on like birds of paradise, and they may have been used for the same purpose. Again, this dinosaur definitely wasn't flying, but it was using its feathers for something. Sinornithosaurus millini almost certainly couldn't fly, but it was pretty close too. Its shoulder structure is nearly identical to that of Archaeopteryx in several respects, including the shape of its furcula. The one requirement for flight that it was missing is fully developed modern feathers. Its feathers consist of shaggy fibers that attach to a central shaft, and these would have lacked the interlocking aerodynamic function necessary for flight. And this is another dromaeosaurid, similar to Ostrom deinonychus. Recall that Greg Paul predicted that dromaeosaurids would end up having feathers back in 1988. This animal was discovered in 1999, and it was the first basic irrefutable proof that he was right. So he was able to predict this a decade before it was discovered. Velociraptor mongoliensis. This is a dinosaur that most people are familiar with. Like all dromaeosaurids, Velociraptor has that enlarged claw on the second digit of its foot that it would have used for killing prey. Since the fossil of Sinornithosaurus showed feathers, this very closely related dinosaur probably would have had them too. But this was confirmed empirically for the first time in 2007 by a very well-preserved fossil of this animal's arm bone that showed the remains of quill knobs. And in modern birds, quill knobs are these little bumps on the bones that are the attachment points for the quills of the feathers. So in Velociraptor, these bumps could be nothing else. So this proved that this dinosaur also was feathered and probably had wings, even though it was too big to fly. So most people are familiar with this animal from its appearance in a certain movie. You know, the big scaly lizards that went click-click in the kitchen. But since 2007, anyone who draws this animal looking like that is not only defying what we know from inference from this animal's relatives, but from the fossils themselves. So these animals were definitely feathered. Ginfamopteryx elegans was quite bird-like in appearance, but this was a troodontid, related to Meilong that I showed earlier. This fossil has beautifully preserved feathers all over its body also, including these very long tail feathers that were kind of similar to the tail feathers in Archaeopteryx. Trooodontids are a unique group of theropods with among the highest brain-to-body ratio of any dinosaurs. They also possess particularly large eyes and well-developed hearing, so they're kind of like the owls of the Cretaceous. Trooodontids also have enlarged second toe claws, and you can't really see it on the fossil, but I think you can on my illustration. And they probably would have used them for killing prey like dromaeosaurs also. And Genphainopteryx was the first troodontid fossil discovered with preserved integument, but it is likely that all troodontids were feathered. Anchiornis huxley was a particularly bird-like troodontid. It was so close to the line between bird-like dinosaurs and dinosaur-like birds that it's difficult to tell for certain which side it was on. Due to its primitive wing morphology, it almost certainly couldn't fly, but its fossil shows that it had pretty large wings, as you can see here. And the fossilized feathers of this animal also contain the same type of pigment structures that are found in Sinosauropteryx. In 2010, by analyzing the distribution of these pigments all over its body, paleontologists were able to determine the actual colors that Anchiornis possessed when it was alive. And thanks to this study, the way I painted it here isn't a matter of guesswork. It was really black and white with barred wings like this and a red crest and red markings on its face. So it's very reminiscent of modern woodpeckers. Recall Microraptor Dewey from William Beattie's Tetrapteryx prediction. This tiny dromaeosaur really did have 4 wings, and each feather on its wings, leg wings and forewings, were asymmetrical. Asymmetrical feathers are only found in animals that actually fly. In modern flightless birds like ostriches, all of its feathers are symmetrical. The purpose of asymmetry in flight feathers is to act as sort of an airfoil. They enable the animal to push themselves up in the air with each downward flap without pushing themselves down with each upstroke. It's unclear whether Microraptor was really capable of powered flight. This has been a subject of much disagreement in paleontology. The more or less consensus at this point is that it probably couldn't fly, but it would have been relegated to gliding, kind of like a flying squirrel. And this is another example of a fossil that was subjected to a pigment study with preserved melanosomes. And this study revealed that this dinosaur was dark in color all over its body, and the structure is also indicative of iridescence. So it would have been black or blue and shiny, kind of like a crow or a blackbird. Archaeopteryx is from Germany's famous Solnhofen quarry. Microraptor, as a dromaeosaur, has all of the same skeletal similarities to Archaeopteryx that were described in Deinonychus. And these traits include large, retractable toe claws and similar plumage, like asymmetrical flight feathers. And this animal had these remnants of leg wings that William Beattie thought were sort of starting to be lost in this animal. So Microraptor and Archaeopteryx represent the smallest possible difference that can exist between 2 animals where one is considered a bird and one is not. Jaegelornis prima is very similar to Archaeopteryx in most respects. It possesses most of the features Archaeopteryx had in common with theropods, such as teeth, a long bony tail, gastralia, and claws on 3 fingers that remain unfused throughout its life. But if you look a little closer, you can see that Jaegelornis is starting to refine some of the flight characteristics that appear in their most primitive form in Archaeopteryx and Microraptor. Although Jaegelornis still has 3 dinosaur-like clawed fingers, these are considerably shorter and more robust than in some of its predecessors, like Archaeopteryx. Jailornis also only has a few teeth at the very tip of its lower jaw. Microraptor and Archaeopteryx both had full mouthfuls of teeth, and all living birds lack teeth entirely. If Archaeopteryx straddles the line between what can be considered a bird and what a dinosaur, Jailornis is a small but unequivocal step down the path towards modern bird anatomy. So, as you can see from this sequence, feathers were not necessarily used for flight. And in fact, it seems like true flight was restricted to a pretty specific sort of feather. So how did feathers evolve, and why? The animals that I just showed here, roughly in sequence from less bird-like to more bird-like, also show a rough sequence in feather development. And this is consistent with a model proposed by ornithologist Richard Crum in 1999. According to Crum's theory, the first evolutionary precursor to feather would have been simple fibers shown in stage 1, and these would have been useful for insulation if the dinosaur was mostly covered in them. By branching into down-like bundles of fibers shown in stage 2, the insulatory abilities of these feathers would have been improved, and they also might have been useful for repelling water and keeping the dinosaur dry when it rained. In stage 3, we've got unbranched barbs attached to a central shaft. And these sort of feathers would have been useful as a way for dinosaurs to display to rivals or to potential mates. And if these feathers were barred or had other patterns, they could have been useful for camouflage. In the stage 4, these barbs would have themselves been branched into barbels, which would have made it possible for them to use them for gliding. And finally, the fully developed flight feathers found in stage 5 are basically the same as those found in modern birds. And the animals that had feathers like this would have been actually able to fly. One interesting thing about this sequence is that it shows exactly how an irreducibly complex structure can evolve. Modern feathers are irreducibly complex, meaning that they cannot serve their current function, flight, without a large number of separate parts working together. A popular argument in the intelligent design movement is that irreducibly complex structures could not have evolved, because each stage in the evolution of a structure must provide an advantage to the animal that has it. Yet anything only part of the way to an irreducibly complex structure would be missing some of the parts that it needs to function. So structures like this couldn't serve the current function, but feathers are a great example of how precursors to this function could have still been useful for other things like insulation, camouflage, or display. So here's an example that I drew of Microraptor using its long arm and leg feathers in a threat display, like to a rival or a predator. And this is actually based on a photograph of a Eurasian eagle owl doing the exact same thing. So a lot of modern birds do this also. Creationists are obsessed with the idea of drawing a line between bird kind and dinosaur kind, because they cannot accept that any kind of animal can change into another kind. But when presented in a sequence like this, it's impossible to be certain, and on what basis, where to draw that line. Modern Linnaean taxonomy runs into the same issue, which is why it's slowly but surely giving way to cladistic taxonomy. For anyone viewing this topic from a creationist perspective, the unavoidable dilemma is shown here. In some cases, these animals would be related to one another because they belong to the same kind, and they have all of the similarities that one would expect based on that. Yet, in other cases, although the physical similarities between them are enough that they could have been related, this relationship would be an illusion. And God, the supposedly omniscient and benevolent creator of all of these animals, would have to be deceiving us by making it look like these animals are related to each other, even when they're not. To anyone who is familiar with these animals, it's apparent that an evolutionary perspective is the only way to avoid making God look like he's dishonest. American Christians must choose whether or not they wish to make themselves enemies of the field of evolutionary biology. If they choose not to, it will require accepting that a literal interpretation is not the right way to read the first part of Genesis. On the other hand, if they choose to reject the conclusions of these fields, it will prolong the stalemate evidenced in the Gallup poll. And this poll shows the situation's outcome. The percentage of Americans who are creationists has not meaningfully changed in over 3 decades. But there has been a decline in theistic evolution and a rise in non-theism. If creationists continue trying to force a choice between evolution and Christianity, there will be more and more evolution-accepting Christians who give up on their faith. And people who give up on creationism will be more likely to abandon Christianity entirely. Christians can accept that God deliberately designed the elegant laws that govern evolution, and that he left clues for us to uncover this brilliant piece of artistry and engineering. Such a valuable gift should not be denigrated, but should be used with a full appreciation for the beauty of life on earth. Thank you.
I bet you we have time for a question. Do anybody want to ask questions? So, Ms. Willoughby, make comment, statement, rebuttal? Who wants to start us here? Yes, right there.
Thank you. It seems like the purpose of this talk is to convince some of these creationists that they can believe in both. And but looking at that graph, it looks, I mean, people have been trying to do that for many years. And it hasn't gone anywhere. So I really wish you luck with this lecture. But your statements about Richard Dawkins and the new atheist methods not working, I don't know how that's supported by data. If anything, it looks like since that kind of movement has started, that there's more people moving not from the creationists, but the people who are sitting on the fence between evolution and God did it and there's no God. And that is rising. That is rising. And the middle people are the ones that are going to be convinced. I'm not sure we're going to be able to they'll just come up with another split, you know, just like you said. They'll put that sign somewhere.
Yeah, well, I think that Dawkins is really, and other scientists like him, are really useful for the fence sitters. And Dawkins has been writing from this perspective for several decades now. But the hardcore creationists are the ones that seem to not be budging at all. And nothing that Dawkins and his cohorts are trying seems to be making a dent. So what I'm saying is that it's time to try a different perspective that takes more, that uses sort of human psychology and a little bit more sensitivity in trying to get through to these creationists. Because as long as they have such power in politics and education, it's something that we can't just ignore. I mean, something needs to be tried. And what we've tried up to this point doesn't seem to be doing much good.
Read.
Were there rat-type birds on the ark? So you have
Have you ever been to the Creation Museum? I'm not sure.
No, I haven't
been either.
I'm reluctant to get into anybody, to be honest. So I imagine that creationists would say that there was one type of rat type that was on the ark, and once it got off the ark, it differentiated into ostriches and emus and kiwis and everything else.
Perhaps God is an exaptation.
Yeah.
Actually, Dr. Wise, now that I think about it, a lot of pictures have the birds flying above it. Were the birds actually on the ark, or were they sort of just hovering?
Rat-type birds don't go.
So just one or two on foot, and the rest all hovering above. Other questions? Yes, young man back there.
So what would like a creationist explanation for vestigial traits be?
Well, I think that some creationists would say that these vestigial traits actually do have some benefit and science just hasn't discovered what they are yet. I know that that's how a lot of people regard the appendix in humans, that it still has some like immune function, I guess. I think most creationists would say that vestigial structures have some use that God intended, but that hasn't been discovered by science yet.
Are you willing to accept that? I mean, if they ask you that question, are you willing to argue that for that little that little fifth digit that's going away?
Well, I wouldn't accept it, no. I think that that's one of the reasons why creationists need to give it up, because this can be shown that it doesn't make sense. That, I mean, things like that vestigial fifth toe, why would God do that? You know, it doesn't really make sense. So.
This gentleman right here in the middle, yeah, is the widespread resistance against accepting evolution mostly a Western Christian cultural phenomenon, or does it show up in other cultures, possibly for other motivations?
I'm mostly just familiar with it in the U.S., but I've looked at the polls, and there does seem to be a fair body of creationist sentiment in the UK and in Australia. I don't think that they have as much desire to like affect education and public policy. I think that other religions also have a creationist undercurrent, but I'm mostly interested in combating this in the U.S., and I wish the rest of the world the best of luck with the hearing battles.
Yes, Lauren.
So when you're directing your arguments, you're directing them towards that upper bar and the Gallup poll, and not really towards the one in the middle?
Well, we have two audiences in mind. One is creationists, obviously, but the other, we're also trying to get through to, I guess, the sort of the new atheist movement, and people who are really militant about just using sort of the Dawkins method and arguing against all religion. And I'm trying to say that that's a different argument, and it's not really useful against creationists at all. And that we're trying to encourage a different approach from the atheist perspective also.
Let's adjourn out to the atrium. We have a birthday cake for Charles Darwin, and thank Ms. Willoughby once again.